just me on the recording, not you guys. All right. So the baseball player pitches a throw at 45 meters per second. It is important to put the units for now in case we have to get rid of them later. And then Francisco correctly said 0 is the speed of the baseball at the beginning. Next, we have this 1.2 M. Still getting to know your names. Michael, what is the 1.2 going to be? What letter do you think is going to be 1.2? You can choose from X, A, or one of those. X or A. What do you think? For 1.2 M. X, Y. X represents 3 different values: distance, length, or X. Okay, passes over there. And that's the official restroom pass table. So write that down if you have to. X equals length. Make a note for yourself. X equals length or distance. And then sometimes it's called displacement. This baseball has moved. Leave it over there. That's the restroom table. Okay. X is the length the baseball has moved. Because it says it right here. Displacement of about 1.2. So you can even draw yourself a picture of this right here. This is the baseball moving. Okay. Now I wrote 2 X's. Why do you think I did that? Michael. The distance has a beginning and an end. So do you think distance will be X 0 or XF? XF. XF. What does F stand for? Close. Final. Final. So make a note for yourself. XF is the final distance of the object. So I have a little picture here. And then X0 is when the ball has not moved. So you're going to have X, sometimes it's XI too. I'm sorry, it's so confusing, but all these physics books and teachers decide sometimes we'll use X0, sometimes we use XI, sometimes we use V0, sometimes we use VI. It's just going to happen.
Wait, I have a question.
Yes.
That's not the same one as this one, no? Yeah, but that's 1.2.
You have a different.
Oh.
No, we're on the other number one.
Oh.
We're on the other number one. Sorry. The first 3 number one, the first 3 questions is supposed to be the same thing as yesterday's quiz. And then the last 3 number questions are different for today. Okay, so we have an XF and an F0. Michael's helped us see that XF is 1.2 M. And X0 is probably what, Michael? 0. Okay, because that's when the ball did not start moving. All right. This question's asking for average acceleration. Let's ask Emiliano, what letter should be represented by acceleration? What letter? A. Now go to your packet and find me the equation for A. It's going to be here. You have your packet, second page. There's constant and then there's average. So what is going to be the equation for average? There's several. So Emiliano, do you know which one is probably best for this problem? We look, there's going to be several options. we have these four. Now, one of those four, are you looking at your paper? One of these four doesn't have T. And that's how you know which equation to use. So which of those four does not have T? The fourth one. So we're going to write that down. That's the one we use for physics today. Right here. So that's going to be VF equals square root of VI squared. Good thing we talked about VF and VI because otherwise we wouldn't know. VF is final velocity. VI initial velocity. VI is 0. V sub F is 45. Plus 2A triangle X. Now, if you're wondering where the heck the equation came from, that's a very good question. Whoever decided to get famous and put this together decided every single physics student on the planet is going to use this. Every single physics scientist is going to use this. So we just have to use it. I'm sorry, I can't tell you the story, how this came to be, but it's going to be something we use to solve for problems. Usually students who have the most difficulty in physics are the ones asking why. And if you don't get that question answered, you start to lose interest. I'm sure you guys were all wondering, right? Where did this formula come from? Did I invent it? Did I make it up? No, this is something we just have to do as a physics student. Just DD2. Our room is D2. Oh, yeah. So this one is D2. This is for Jose. Are you here? Step out. All right. Back to Emiliano. Are we trying to find A or VF? What do you think? We're gonna find A. Does this formula that we've never seen before until you came to this class, does it have A by itself? No. So what are we probably gonna have to do to get A by itself? You remember the steps? Okay, the first step is this big square root. We have to get rid of it. Do you remember how to get rid of it? You hear what he said? Square it. Okay, so let's square it, everyone. And that's why I kept squaring it in the notes for the lecture and for the group quiz. I took big old parentheses. I'm going to make them red. And I'm going to square not just one side, but the other side so that the square root is no longer there. I'm going to rewrite everything now. VF. Let's write it in black. Equals VI squared. And it's VF squared. All right, we called on 2 students. Let's hear from Jordan. Jordan, where did this 2 come from? Any ideas? Where did this 2 come from? Because we squared it. And why did we square it? Ask him, he knows. Why did we square it? Of square root. All right. So whenever we're trying to solve for A or for X, we have to do the square root to this really awful formula. I didn't mean to burden on you in your life, but it's just something we have to deal with. Okay. It's like the law, the California standard. So yeah, I don't do this for fun. It's not fun. This is it's part of my work. I don't hate it because I got used to it. You'll get used to it too. Okay, I promise. Just like a language. All right, we've got these 2 squared. Jordan, what do we do next to get A by itself? Because Emiliano says A is very important to find average acceleration. We can divide or multiply, but to do the process order of operations, you have to do the outer stuff first. Remember order of operations? There's parentheses, exponents, multiplication, division. Did you guys learn PEMDAS?
Yeah.
Okay, so Jordan, when you have a bunch of stuff slammed together, to get things by itself, you have to work on the outside first. So to get rid of this, we have to do what's being opposite of what's happening. Subtract. So let's do that, everyone. So you're going to take your v sub I and subtract it from the left to the right side, but we're going to do the same thing to the left side so that we have no more vi squared on the right side. So I'm going to rewrite it now. Okay, next is Alexander. Which one's Alex? Yeah, all right, Alexander. What is the next step to get A? Divide by what?
2 delta x.
2 delta x. Why? Why would we do that?
A by itself.
The A by itself. Alexander sees that 2x is multiplying to A, so we have to do the opposite of what's being done. That's why it kept being shown over and over in the notes. Not because I want your life to be miserable, it's because I want you to see how it became A. So now we have a final equation. I'm going to shrink this down for my housekeeping. Let's go with this. It's too much. Okay. And now rewrite this as VF squared minus VI squared all over 2 delta x equals A. Put a nice circle around it so you can keep track. And now let's plug in and solve. Back to Francisco. What is our VF?
45 and
All right.
the VI.
Yeah. What's our VI?
0.
0. And it's so nice that it's 0 because now you don't even have to do 0 squared because it should be 0 in your heads. And then we divide by 2. What's our delta x? Or yeah, what's 1.2 minus 0? Because that's what delta means.
The same number, right? Oh,
Well, I wanted to point out delta x means final x minus initial x. So we did 1.2 minus 0. 1.2 minus 0. I think in my notes, I just went straight to xf, but it's the same thing. All right, so let's do the work now. Let's do the calculations. Let's calculate. All right, what is our 45 squared? 2025. What is our 2 times 1.2? 2.4. What is your final answer? Only Francisco. But thank you for leading.
So what is it? I divide, right?
Yeah, this one.
$843.75.
Who else got that? Anyone else? Did you try it? Try it out. 2025 divided by 2.4. So far, 2 students have gotten 843.75. Let me know what you get. 2025 divided by 2.4. What'd you get?
Wait, what did you say?
What was your answer?
843.75.
That's what they got. How about you guys? Same? All right. I did too. Well done. You got your first acceleration for this problem. Okay. All right, let's do the next one. That's a very fast baseball. This is number 2. Delete all this. Give you a link. Copy. Schoology. Paste. Link to. All right, click on that. Refresh your page and go to link 2. Oh, I have a different title. That's why. This is V2 24. External number 2. All right, let's do this. The next question is going to be right here. A sports car accelerates to 100 kilometers an hour. All right, Michael. What's the first thing we should write down after looking at this question? What? V, okay. And what does V equal? Yeah, kilometers per hour, right? And do you think this is VF or VI or V0, which is the same thing as VI? V what? V0 means it's not moving. V0 means it's not moving, so it has to be VF. But what does the F stand for? F stands for final. Final, yeah, make a note. Make a note so you remember on your paper. V sub F means final velocity. Okay, make a note. I'm not gonna write it here. I don't have space. Okay, next is what's the next information we do? Let's just go in a circle. Jordan, what's the next information in our problem that we want to write? Yeah, sports car. We're on the second number 2. .5 seconds. What letter should we represent that with? If it's in a formula. X is length, right? X is length. T for time. Is that what you're gonna say?
Yeah.
T for time. So let's put T. And now we're going to look at what we're asked for. Emiliano, what are we asked for? Average acceleration. What letter should we use? A. Okay. Everyone, we're looking for A. So in this problem, we don't need to find X. We don't even need to mess with X. We're just going to look for A using V and T. Emiliano, flip over your packet or go to the packet and see where is there an equation that helps us find A with V and T. Yeah, it's on the second page. Which row? It's either the first, second, the 4th, 5th, 6th, or 7th row. Which one uses V and T to find A? Can't be the last one we used. That one uses X. And the second to last one that has X also. So it's either the fourth or the fifth one. Which one is probably easiest? We're on the back of the first page. Back of the first page. Yeah, back of the first page. We're on the third and fourth row. Third and fourth row. Which one? So the third one. Okay, let's try it. Let's try it. Let's go to our assignment. And let's write down A equals triangle V over triangle T. Now that's the same thing as V final minus V initial, or T final minus T initial. That's what that triangle means. Every time it meets subtraction. Sometimes you can ignore the VI and the TI because that's usually 0 unless the problem says so. And our problem doesn't say the VI is moving. They say at rest. Right here it says at rest. So VI is going to be 0. All right, let's see what we should do next. Alexander, 100 km per hour. Can we put that into our formula right away? Why? Why do you think that? We have V, we have T, but this S is going to stop us from using what's given to us, like this S right here. Our V also has to be in S, seconds. Otherwise, it's not going to give us the right answer. It has to be per second. So everyone convert 100 km into meters per second. So 100 km. And the way I convert is turning it into a fraction. Now, this is where a lot of students go do their own way. Some do it in their heads. Oh, I just multiply by 1,000 and divide by 60, divide by 60. Okay, that's fine for these types of problems. But if later on, if it gets really complicated, you have to do it this way. You make your initial units as a fraction, and then you're going to multiply it by another fraction. That's the only way to turn seconds into hours and kilometers into meters. It's called the conversion factor. So, Alexander, how many kilometers are in, how many meters are in 1 kilometer? Should be in the packet. It is not, okay. So kilometers, it's given to us in miles. So next time I teach this, I should have you see a chart where 1,000 meters equals 1 kilometer. Okay, so make a note, 1,000 meters equals 1 kilometer. So that's something you remember. Anytime we use meters and kilometers, 1,000 meters equals a kilometer. So that's why I kept writing this over and over in our answer key. Those look like 6s, so I'm going to make this 0. 1,000 meters over kilometers. This is going to help us turn kilometers into meters because the same like terms will cancel out. So let's do that. Kilometers and kilometers are now going to cancel out. Right? Now we're not done because we have to turn our our hours into minutes. So let's go ahead and do that next. So I'm gonna use another fraction. And I'm gonna put 1 hour at the top. And Michael, how many minutes are in an hour? 60. Like that. And now I can cancel out my hours because some like terms are on the numerator and the denominator. So I'm gonna go ahead and cancel that out. Make that red. Make that red. Now, Michael, we're not done because we needed seconds, not minutes. So we have to do this one more time. Use a conversion factor. What is the number of seconds in a minute? 60. So I'm going to do this. And now we can multiply across and get a final answer for just finding V. Now, a lot of students in the quiz, they stopped here because it looks like the math is done, but it's not. It's only halfway. So let's also cancel out minutes and minutes. Then we'll rewrite this. (100) times 1,000 all over 60 times 60. All right. Michael, you're up. No, whose turn is it? Is it your turn? Yeah, why not? Alexander. Multiply 100 times 1,000. Right? 100,000. And then 60 times 60. And then what is the 100,000 divided by 60? 360. That's right, 3,600. 27.70. And now we round at the hundredths. So we're going to make it 27.8. And this is just our V. Okay, we just found V sub F in meters per second. The whole goal is to find A. Remember what Emiliano said? So we got to find A. So now we plug in A equals, and then we put in V sub F. And then we divide by our T. All right, Michael, give us our acceleration. Yep, and everyone do the same. Let's try to get the same answer.
It's the point.
Okay, anyone else get that?
6.17.
Yeah, that's what he said. You got that? How about you guys? 6.17? Okay, write that down. Nice job. Okay, so that's how you find acceleration. All right, let's keep going. Last but not least, number 3. This is number 3. Let's go to the problem here. It's gonna be small plane. Right. Okay, let's take the link. Anyone with link, copy. Paste it into. History, physics. All this 3. All right, go to Schoology. Click on 3. There. All right, almost done. So this is how your test is going to look, and your study guide has similar problems. Let's go with Jordan. What is the most important thing to do first? That's word problem. We've got these numbers. What should we do with the numbers? What should we do with it? Write it down. So what should I write down? Okay, all right. And what does that equal? Now, m/s is meters per second. So is that going to be velocity? Is that going to be x? Is that going to be time? Acceleration? What do you? Velocity. So let's use, and then is it VF or VI? VF. Okay, what does F stand for? Final. Okay, so now we've got our VF. Next is our speed, or our number. So Francisco, we're now on number 3. You can go to Schoology, refresh your page. Still with Jordan, what should we write for 3.00 meters per second square? What variable should that be? Your options are X, A, or T. It says right here, this accelerates. So A. Sometimes the problem helps when it's there. I mean, here it didn't say V or velocity. Okay, Emiliano, what should we do with this 200? What should that variable be? M is meters, which is what we put for our final answer. But in our equations, there's no M. It's either V, A, X, or T. So X. Sometimes X is another letter. Do you know which ones? Make a note of this. Sometimes X is L. Sometimes X is D. And then like next month, we'll find out it's also R. But it's good to make note in your mind, on your paper somewhere, X is not always going to be X. Sometimes it's L and sometimes it's D. It's very annoying. I wish I made the rules, but I did make the rules. Okay. And it's either XF or XI. Which one do you think it is? X, which one? Yeah, it's either XF or XI. Okay. All right. What do you think? Is what does I stand for? You know, write this down. XI stands for initial distance. Initial distance is XI. And that means it's most likely going to be 0. It's like the distance before the object started moving. So XI is going to be 0, which means 200 is X. What's the other letter? XF. XF. What do you think F stands for? You gotta write this down. Final, write it down. If you wrote it down before and you forgot, write it down again. XF is final distance. Final distance. Okay, what's the question asking for? Alexander, it's asking,
Plane can reach the proper speed to take off.
reach the proper speed. It's not asking for acceleration. It's asking for speed. So what letter is that represented by? How fast something moves? Is it gonna be V, A, T, or X? V. Now we already have a V, but this V is only for takeoff V, right? It says right here, a plane requires this much speed to take off. So we're gonna find VF again, and we're gonna see if it's 33.3 or more, if the plane takes off or crashes. So that's what the question's asking for. So we're gonna find VF on our own using 3 seconds and 200 meters. So which equation should we use? Francisco, you catching up to us?
Yeah.
Okay. So we're on the back. Which equation uses V, A, and X? No T.
No T, right?
Yeah, no T
Out of these four,
out of those four.
I think this one is the third one.
Let's see. So when you say third one, you're saying
Displacement was constant at stabilization.
the displacement. So that one has T in it. Underneath that, it says,
The final.
yeah, final velocity with constant acceleration. Okay, so let's write that down. Going to be the same thing we've been using from before. VF equals square root VI squared plus 2A delta X. So that is our starting point. And Francisco, do we need to square both sides and divide and minus stuff?
Yeah, because that's a power of 2, right?
And that's a power of 2, but we're looking for V sub F this time.
Oh,
So sometimes you have to solve for A and X, sometimes you don't. This time, it's gonna be final velocity, because it's asking for the proper speed.
okay.
So we're just gonna put numbers in. It's very nice when that happens. So VF equals, go ahead.
When it says like to like find the speed of it,
Mhm.
we just input the numbers.
If that's the equation you chose.
Okay.
Yeah,
So if there's no number but outside the square root, we just look for the number most time.
correct. Yeah, if you're looking for this, you don't have to square both sides, you don't have to do all those other steps. You just need to plug in the numbers. But if we're looking for A or X, you have to solve for A and X.
Oh,
To get all that, it's a lot of work.
Huh.
It's like extra work. So for this particular step, we don't have to plug in and do the square both sides, minus both sides, divide both sides. All right, so good question. What is our VI gonna be? So, Michael, what do you think? We didn't write it down, but it's about an airplane that's gonna take off. Now, airplanes, they're not moving in the beginning, and then they move when they take off. So what's the speed when airplanes are not moving? What number should that be? 0. So that's why for VI, we're gonna put 0, then we put 2, then what's our A, Michael? 3.00, and then our X, our change in X is, remember, change in X is X final minus X initial. What? X5, XF?
Yeah.
XF, final, X final, yes. So we'll put in our 200. And now, Jordan, go ahead and do the math for us. Multiply all that stuff in the middle before we take the square root. Everyone with the study guide, I'm gonna post the answer key to the study guides in a moment. But you can start unlocking your phones, start your game ready to go, because we're almost done here, okay? All right, Jordan, what does all that inside the square root equal? What'd you get? All right, everyone do it in the group. And we're gonna move the test to Tuesday, okay? We're gonna move the test to Tuesday. Review game will be on Monday. What'd you get? Okay, so do this, do 2 times 3 times 200. And then tell us what to write down. And then we'll compare what everyone else got. Anyone else get that?
I don't know how to input that.
Okay, you got it? We're not doing the square root yet. We're just doing this.
Oh,
She said 1200. What'd you get? 1200, 1200, 1200. Okay, write it down. Now do the square root of 1200. How do we do that? You're gonna click second. And then the X2 button. And then put in 1200. So second, the X2 button, and then put in 1200. So Emiliano, give that to us. Who else got that? All right, nice job. Write it down. Now, if we turn this in, we only get half credit, because look, there's a secret question right here. What minimum length must the runway have? So on your test, don't celebrate too early. Right?
you have to round it, right?
You have to replug it in.
Oh,
You have to, oh, I see. You have to round this. Well, you don't have to round this one. This one's 34.64. We found V sub F. This is now asking for minimum length. How short can we make the runway?
34, right? That's 34.
So 34 is the speed. That's the
Oh.
speed of the airplane if the runway was 200. Can we make the runway shorter? Let's save some money on this construction. Can we save money on building a shorter runway? That's now our next job. What's the minimum length? So we now have to find a different variable. So anyone, what variable is going to be length?
The L, right?
Sometimes it's L, sometimes it's D for distance, and X. In this case, right here, we're going to look for X now, okay? I know we had XF here for this problem, but now we're going to find X F for the second problem, because that's what the question's asking for. So we're going to use the same equation, because we're not given time. So VF equals, okay, I'm gonna save you guys time here.
Good afternoon, teachers, please excuse this interruption.
Look
This is a reminder.
at,
I just
number
sent out an email to a
one.
few teachers.
I'm gonna paste this.
Forms for the attendance office. Please check your emails. It went out to the select teachers. If you've not yet turned in your discrepancy forms to the attendance office, please do so this afternoon before you leave for the day. Again, if you have not yet turned in your discrepancy forms for the attendance office, please do so today before you leave for the day.
Or
Thank you very much.
So study guide, please do that at home. I'm gonna post answer keys so you can check your answers. And then you can play the review game on Monday. Yeah, keep everything and work on the study guide this weekend. I'll post the answer keys so you can solve for the correct solutions. Okay, nice job, group. Yes, you finished? Yeah, if you finish the study guide, you can put it in the box. Don't you want to check your answers? Okay, you check with someone else? Okay, that's fine. So let me stop the recording and get everyone ready to go home.